All right, hi there. We are on video number 30. Can you believe you listened to me 30 times this year? Probably seems like 130. Sorry. This is chapter 11, section 7, last section in this chapter. And this is all about probability. What is the likelihood of this happening given this? Or what's the probability of this happening? So there's a whole bunch. This is another one, a lot of writing in this section. So here we go. Any happening, that's strange English. Any happening whose result is uncertain is called an experiment. Period. The possible results of the experiment are called outcomes. And the set of all possible outcomes is called the sample space. Which going forward in this section, I will abbreviate as SS. All right, so there's a couple words in here that we should probably just put a highlighter on. Experiment. Possible results of the experiment are the outcomes, and the set of all possible outcomes is called the sample space. All right, so next, here is the first little example. Find the sample space when two coins are tossed. All right, well, you have coin 1 could be a head or a tail, and coin 2 can also be a head or a tail. And so what we have here is these two things mixing together. So we can have a head, we can have a head tail, we can have a tail head, which is different, right? Because that came from the first coin, second coin versus the first coin, second coin. And we can have a tail. So you could actually draw a line, right? You could go, that could go to that, or it can go to that. And then the tail could go to the head, or it could go to the tail. So you have 4 possible outcomes here. These are the 4 possible outcomes. 4 outcomes. Create your sample space. And then in varsity, they also want to know the number of elements. Well, that would be this. Okay, so the sample space would be specifically these items. Then the number of elements would be 4. Okay, so the number of outcomes are the elements. I guess I kind of worded that poorly. I changed it a little bit from my notes there. All right. From there, let's see the probability of an event. All right. I'm going to move that up the page just a little bit. Let's go with this pink. The probability of an event. Oh, gosh, I don't know. Deer out in the woods, I guess. If an event E oh, no, there's a car. Hey, guys, it's okay. Shh. It's just the neighbor. Be quiet. If an event E has Dixie, N to the E equally likely outcomes, and its sample space big S has NS equally likely outcomes, comma, the probability excuse me, of event E is given by P of E is equal to N of E over N of S. So what is the possibility? What are the outcomes over its sample space? All right, so here is how we are going to actually use this. All right, so we have, what is the probability of drawing an ace from a standard deck of cards? Okay, so couple things. Along with this lecture, I have included two pictures. One picture, which I'm going to throw on the screen but then get rid of, is this. And it is just is it going to actually like load? It is a picture of a deck of cards. There we go. It is a picture of a deck of cards. And some of you may be more familiar than others with what is the actual cards in a deck of cards. There are 4 suits, right? The suits are the types, I guess. They all go together. These are the clubs on top, spades next. Clubs and spades are all black. Hearts and diamonds are all red. There's 13 cards in each suit, and they go ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And I kind of laid those out for you. So I don't know how many of you do play cards, don't play cards, what your familiarity, but you need to have an idea. So this, I'm not going to leave this on the screen, but it is included in the lecture. So you can open that up and reference it if you need it. So there's 4 of every denomination, 4 aces, 4 twos, 4 threes, 4 fours, so on and so forth. There are, as I just mentioned, there's 13 of each suit. So there are 52 total cards in a deck. It's important that you know that. We're talking with no jokers in the deck. All right, so that's the information that you have. So given this, what is the probability of drawing an ace? So the likelihood of drawing an ace, well, there's 4 of them, right? We have an ace of clubs, we have an ace of spades, an ace of hearts, and an ace of diamonds. So there's 4 aces in the deck, and there's a total of 52 cards. So our expected outcome, I need a pen. Our expected outcome, our probability of drawing an ace, our expected is 4 out of 52 cards, and you should always reduce these things. So this is 1 out of 13. Okay, so that's how that's going to work out. All right, next. Paper. Okay. Two-sided dice are rolled. I should probably spell that out. That was a poor choice. Two-sided dice are rolled. What is the probability that their sum is 7? So we want probability sum is 7. So another picture that I provided you with is something I pulled off of another video somewhere. My dogs might explode again. Sorry, car outside. So what we can do here is just take a look at this thing, and I'm going to, so these are the die, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. He color coded them, and then what he did was he wrote what the rolls that are expected. So you could get a 1 and a 1, a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, so on and so forth. So what we want to do is, where are these going to equal 7? Well, this guy, for example, only a 1 and a 1 is just 2, right? So that's not going to work. 3, 4, 5, 6. Well, here's a 7. This is an 8. Well, here's a 7. And then if you actually look around, what you'll see is that the 7s go up in a diagonal, and nothing else in here makes 7. So also, you'll notice that we have 6 and 6. So we have a total of 36 possible rolls. And we have 1, 2, 3, 4, 5, 6 that are 7s. So we have 1/6 is the possibility that you have a sum of a 7. Okay. This picture right here is also included as a picture because there are a couple varsity questions that ask for different things, like what's the likelihood of rolling doubles? What's the likelihood of the sum being less than 6? Those kinds of things. So I thought it would be easier if I just gave you that picture that you could pull up and look at and have at your disposal. So you don't have to copy it down on the screen. Just be aware that it's available to you. Dixie! Gosh, I live in the middle of the woods. You wouldn't think it's that exciting. Really. I'm going to choke her. Hold on while I go put her outside in the freezing cold until this video's over. Come on, you can go outside. Shut your mouth until I'm all done. And freeze, probably. Yep, you can go freeze. There you go. Go freeze. Have a nice time. Okay. Very sorry for the interruptions that keep happening. Wish I could pause this and edit it, but I can't. And I've been doing this all weekend long for about the last 27 hours. I'm not pausing. You guys are just going to have to deal with the interruptions. Sorry. All right. Next question. New screen. Paper. All right. In Delaware's lottery. Oh, that's not even a pen. In Delaware's lottery, a player chooses 6 different numbers from 1 to 35. Now notice it does say different numbers. They can't repeat the number 1. What is the probability of winning if the order of the numbers does not matter and the ticket buyer purchases only one ticket. All right, so notice we have this statement in here. Order of the numbers does not matter. Well, recall from the last chapter, and I'll write this down in here, that we had combinations and permutations. Can you remember which one order mattered and which one order did not matter? It was combinations. Order does not matter. And in permutations, the order does matter. So it's important that you keep those guys straight. And so here, a lottery player is choosing 6 different numbers out of 35 numbers. So we're going to do a combination of 35, choose 6 to get our sample space. This will give us our sample space. Okay, so I already figured that out in Desmos, and that gives me 1,623,160. That's my sample space. Now, this piece of information is also important, that this person is buying only one ticket, because now the probability of them winning with that ticket, well, they're only buying one ticket, and the sample space is that. So this is the likelihood that they're going to win. 1 in over 1.6 million. Lottery is huge right now, by the way. Huge, like $800 million. Anybody playing? It's huge, huge. Okay. All right. Oh, there is a lot of writing on these couple pages. Holy moly. Okay. The next couple questions are a little bit weird. So we'll just scroll down a little bit. And I'm going to do this. And these have a totally different look about them. They look like this. They look like something where you're given the probability of A bar B. And this means the probability of A given B also happening. So we have a couple of interesting things here. And so here's how this is going to work in this. I'm going to give you a couple of specific problems. This one looks like this. You draw a marble from a jar. And that jar contains 6 red marbles, 8 green marbles, and 12 blue marbles. What is the probability of drawing a green marble? Given that you did not draw a red one. All right, so here's what this looks like in varsity. Looks like the probability of green given not red. All right, so here's how you're going to do this. And remember, A given B. So what you are going to do, number one, is you are going to eliminate the items in B because it says not read. Not read. We are going to eliminate the items in B, so in this case the red marbles, from the original sample space. Okay, so if my sample space started out as 6 red, 8 green, 12 blue, and we're now saying it can't be red, well, it can't be red, so we're going to take the red out of there. So my sample space is now only 20 marbles, okay? Sample space is now 20. So let's see. Now, step 2, don't have any green in here. You are going to find the probability of just the event A happening from the remaining sample space. So we've pretty much eliminated this. We've gotten rid of it completely. So now we're just finding probability of green. And we know that we're working out of only 20 marbles. We have 8 possible green ones. So we reduce that. 4 goes into both of those 2 times and 5 times. So 2/5. And that's the answer to that guy. Now, note that these are only eliminated because of the wording here, not. If this is not a negative, then you're limiting your sample space to those items. Okay? So this is kind of a, let's add this little note in here. Okay, so we eliminated the items because of the wording. But if you're talking about, I don't know, the alphabet, and we're going to pull something from the second half of the alphabet, well, we're only going to be using from N to the end. I don't know if M is the actual middle. I'm just saying. Okay, so you would limit your sample space to those specific items. Okay, you're only eliminating in this case because of the wording of not read. All right. Next, some terminology in probability. Okay, so a union looks like a U. We've used that actually in some domain and range, right? So it would look like A union B, and it means A or B. So a union means or, and it mathematically it means A plus B. So that's important. Super important, actually. Intersection is an upside down capital N. It looks just weird. Looks like A intersect B. Oh, that's not the word I want. A intersect B. It means A and B, And mathematically, it's A times B. All right. The other thing you need to know is the not. This is called the complement. And that is spelled correctly. It looks weird because I think in English complement has an I in it, but in math, complement has two E's. And let's see, here's what it looks like. If normally you're talking about A, then not A is A with a little hyphen after it, and it means 1 minus A mathematically. So if you want to find, let's see, is there an example in here? I don't know if I have one in my book. I did have one somewhere else. Let's do this. What is the probability of pulling a card from a deck that is not a 5? Well, first you would have to find what is the probability of a 5. And there's 4 5s in a deck out of 52 cards, so that would be 1 out of 13, I think. I don't have this on my paper. Flying by the seat of my pants here. Let's see. So 4 out of 52 is 1/13. Okay, so the probability of not a 5 is 1 minus it being a 5. So this would be 12/13. That's how you would do that. It's 1 minus A. Okay, 1 minus the probability of the actual thing happening. Okay, we're getting there. So there's also, you're going to get a problem in varsity where they're going to give you the probability of A is equal to something. The probability of B equals something else. And then they're going to give you the probability of B given A is something else. Okay, so you're going to have 3 pieces of information. And then you're going to be asked to find probability of not A, probability of A and B, the probability of B or A, those types of things. And eventually, down at the bottom, they're going to ask you to find the probability of A given B. Well, this is something called Bayes' theorem. And there's a formula for that. And all you need, and I'm not going to work this out. This is just plugging and chugging. You're just going to go P of A times P of B given A over P of B. Okay, so you're just going to, and you're going to have all of these. These will all be given in the problem. Okay, so that's just something you're going to need to know when you go to do that. All right. 2 more things and then we're done. All right, so let's talk about probability without replacement. So that means you're going to pull 2 things out of somewhere. Pick 2 cards out of a deck, pull 2 marbles out of a hat, pull 2 cookies out of a jar, or whatever it might be. You're going to not put one back and then pull another one out. So here's a problem that we're going to take a look at. What's the probability? These are actually pretty easy, but if we don't go over one, you won't know how to handle it. What is the probability of selecting 2 cards in a row from a deck that are both diamonds? Okay, well, we know that there are 13 diamonds in a deck, right? So the likelihood of pulling a diamond out the first time is 13 out of 52. We assume that actually happens. So the second time we pull a card, there's only 12 diamonds to pick from because we already picked one out of there. And we've already removed a card out of the deck. So there's only 51. And we multiply those two things together. So when we do that, we get 3 out of 52. That is the likelihood that we will pick 2 diamonds out of a deck in a row. Okay? So that same principle would apply if you had a bag of colored marbles and they wanted to know the likelihood of picking blue then picking green. You would just, whatever the likelihood of picking it the first time. And if you have to take one away, take the bottom away for sure. Maybe you have to take the top away. It depends. All right. Now, the very last thing we need to do. All right. We have to talk about the probability of the union of 2 events. Okay, so we're going to look at this spinner right here that I made. We're going to make that spinner a lot smaller. Let's get rid of that. What was that little? Let's get rid of that little guy. Let's make this dude smaller. Woo! I think I just ungrouped a whole bunch of things that I don't want to ungroup. Okay. That needs to be littler. Pictures never work as well as they're supposed to. This tires me out. I'm exhausted. I want to be done with this. All right, hurry up. It's probably what you guys say. Come on, it won't even move now. Move. It's totally in the middle of my page. Okay. Well, I don't even know if I can write anything. Nope. We're just going to have to wait until it stops resizing. Can you see it? Like thinking and just going smaller and smaller and smaller. I mean, I want it smaller because it's a little bit big. I'll just pause here while it's doing that. I think I should go let my dogs in. They're probably cold. It's like, how cold is it outside? Oh, it's 30. They're fine. Well, we'll see if we can leave that there. Ah! Oh, this isn't great. This better not. This is the very last thing we have to do. I might have to just amend this. That won't even go away. Okay, pen. I need a pen. This is fun. How long do you think this is going to take? Ooh, maybe it's done. Looked like it kind of snapped into place there. No, it's still thinking. I don't know how small it's going to get. Oh, look at all that stuff. I guess I have a pen now. All right. I don't want to press my luck. I just erased inside of that thing. Do I press my... Oh my God. Are you freaking kidding me? All right. Well, can you see it over the side? I'm just going to draw it really fast. I spent so much time drawing that thing for you so you could see it. All right. Well, here you go. I really did. I spent a lot of time drawing that beautiful little spinner. All right. Let's see. I have it on my paper. It's A, B, A, D, C, B. And then this is blue. This is green. This is orange. Or they're close enough anyway. I don't even care if they're turned around. And then purple, purple, purple. Okay, so sorry, it was just gorgeous. Maybe I'll put it back on at the end. This is a real major bummer. So here's the problem. What is the probability? The probability of one of the parts of the spinner being purple or the letter B. Okay, now here's the problem. We have a section here that is both a B and purple. So, this is kind of weird, but there's a lot of writing here. And maybe I won't even write it out. What I've said was you have to be careful with these because of the intersection of events. If this happens, this B is both pieces. It's B and purple. So notice there's a section that's both. So it would get counted twice. And so the formula for an intersection takes this into account. And the formula for an intersection, normally I wouldn't leave that all out. That tells you how tired and irritated I'm getting. Let's see, is the probability of A in union with B is the probability of A happening plus the probability of B happening minus the probability of A intersect B. All right, so this is a... Oh, geez, I wrote intersection. That's incorrect. This is a union. What's actually happening here is a union. But we're taking the probability of A and the probability of B, but then we're subtracting off the intersection because of when this happens 2 times. Now, I mentioned to you earlier that an intersection means multiply. So when I do these, I rewrite this part as the probability of A times the probability of B. So we're going to take the probability of A plus the probability of B. And then this isn't actually terribly difficult. Our A is, what's the likelihood that this thing is purple? So we'll write this all out. So the probability that it's purple or it's a B is going to be the probability of it being purple plus the probability of it being a B minus the probability of it being purple times the probability of it being a B. All right, well, let's take a look. The probability of it being purple, there's 6 sections, is 1, 2, 3 out of 6. The probability of it being a B, there's 2 of them. And then we're going to subtract off 3, 6 times 2, 6. Well, when I did this, I did the 3, 6 plus 2, 6. Well, this is 5, 6. And then I multiplied, and that's actually a 1/6. 5, 6 minus 1, 6 is 4, 6. And then I reduce that to 2/3. And that is the probability of it being purple or a B. And I'm not sure you need to use this in your varsity at all, but if it comes up, I had to use it, but then I think I modified the question so you don't have to. I'm going to try to plop the spinner back in here. Who knows? It might jack up the whole thing. But the notes are done, so you guys can close it out. All righty? Toodaloo.